Hi guys, this is Dr. TS, and today I will be continuing our discussion in our Module 3 on basic chemistry, and we're going to talk about two really cool concepts called isotopes and ions. So if you remember from our previous lecture, all atoms are made up of these subatomic particles of protons, neutrons, and electrons. And we can calculate the number of each of these based on different things. So if we look at the the atom nitrogen, it has the atomic number of 7. So that means it has 7 protons. And remember that protons, neutrons, and electrons are equal. So if it has 7 protons, it has 7 neutrons, and it has 7 electrons. If I change that proton number, so if I take that to an 8, okay, that is going to change my element. I will no longer be looking at nitrogen. Instead, I will be looking at oxygen, okay? So changing the number of protons essentially changes the element. However, you can actually change the numbers of neutrons and electrons and maintain the same element. So you can still have nitrogen, but you can change the neutrons or electrons, and that will change the property of that element. So an isotope is something where we change the number of neutrons. The ions is where we change the number of electrons. We're going to talk about both of these in today's lecture. So let's first talk about isotopes. So isotopes, like I said, are going to be where we change the number of neutrons. And if you remember, neutrons influence atomic mass, right? We said that, atomic mass is essentially equal to the number of protons plus the number of neutrons. So again, going to our nitrogen example, right, has 7 protons and 7 neutrons, and you get an atomic mass of around 14. However, if we gain or lose neutrons, we can then essentially change the atomic mass of an atom. And this is going to change its properties and how it works chemically. So this is something that naturally occurs. This is something we can see in nature. We see these special elements that have changes to their number of neutrons. And when this happens, we call it an isotope. And an isotope is defined as atoms with the same number of protons but different number of neutrons. And we denote isotopes by putting the name. So say if we're talking about nitrogen, right? Nitrogen usually weighs about 14. However, if we add a neutron, we can then call nitrogen 15, and so on and so forth. So let's practice this idea with the element carbon. Carbon has the atomic number of 6. So how many protons will we find in carbon? You would be right if you said 6. How many neutrons would we find in carbon? Also 6. How many electrons? 6. And what would the atomic mass of carbon be? It would be the number of protons plus the number of neutrons, which would get us 12. Okay, so we call normal, old, everyday carbon, carbon 12. However, right, what happens if we add a neutron? We make this 7. Remember, the number of protons and the number of electrons are going to stay the same. But now, what happens if we add 6 plus 7? We get 13. So we call this carbon 13. Let's practice this idea one more time. Let's imagine that instead of 6 neutrons, we have 8 neutrons. Remember, in an isotope, the number of protons and the number of electrons are going to stay the same. We add our protons and neutrons together, and we get 14. So again, an isotope is where we change the number of neutrons, but we change nothing else. And this will influence atomic mass and therefore have different effects on how the element works. Isotopes will not come up a super lot in this class. We really more care about the ions, which we're going to talk about in the next slide, but I want you to be aware that this is something we do see in nature. This is something we can see in our own body. We can see elements in our body have different amounts of neutrons. We can also change the number of electrons. And when we change the number of electrons, this will influence the charge of the atom, okay? Charge. Now, when you think of charge, I want you to think of it going 2 directions, a positive direction and a negative direction. So the overall charge of an atom is determined by the overall number of protons compared to the number of electrons. So if we looked at hydrogen, okay, Hydrogen has the atomic number 1. It has 1 proton, and it has 1 electron. Remember, protons are positive, electrons are negative. So if I added this positive and negative together, what would I get? I would get essentially 0. There would be no charge to it. But what happens if I take away that electron? What would my charge be? It'd be positive, just 1. And so when this happens, we call this an ion. These are atoms with unequal numbers of protons and electrons. And there are going to be kind of 3 ways that we classify this. The first is going to be no overall charge, right? So this means that number of protons is equal to the number of electrons. So in this case, if we have a helium atom, right, which has it has 2 protons, 2 electrons, and the net charge is 0. We call this a neutral atom. It has no charge to it. However, we can upset this balance. So what happens if we lose electrons? So again, in this example, we have helium here. It has 2 protons, 1 electron, right? If you lose a negative, okay, this is where a lot of people get confused, right? If you lose a negative, you are positive, okay? So if you lose a negative, you become more positive. If we lose a negative charge, we become more positive. So electrons are lost, the atom will become positively charged. And we often denote this by putting a little plus sign to the top of the atom. Okay, so this helium now has a net positive. So it's positive. Remember, you lose a negative, you become positive. When this happens, we call this a cation. Now, the way that I remember what we call these is I like cats. I have 3 cats, okay? And I think cats are positive. Yay, positive cats. So I call them cations. We can also gain electrons, okay? So sometimes this happens, you gain an electron. So in this example, we have helium again, okay? But we have now gained more negative. So we become more negative. So instead of a positive, you would put a negative next to your atom's name. We call this an anion. I don't have any fun way to memorize this. I know cations are positive, and I know anions are negative. And so ions are going to come up a lot in this course, and especially towards the end of this specific module when Professor Fanninsteel talks to you guys about ionic bonds. But this is really, really essential that electrons are influencing behavior this way. So let's practice this one more time, okay? So here we have sodium, okay? Sodium. How many protons does sodium have? It has 11. How many neutrons does sodium have? 11. How many electrons? 11. But what happens if I come in and I take away one of these electrons? I say, nope, I'm taking away your electron. Now you have 10 electrons. So I have lost a negative. So now sodium, I'm going to call it sodium plus. It has lost an electron, so it has a positive charge to it. I now have more of these positive charges than I do of these negative charges. I have 1 more positive than I do all my other negatives. Let's take a look at chlorine over here. It has an atomic number of 17. So it has 17 protons, it has 17 neutrons, and it has 17 electrons. Chlorine can sometimes gain an electron. So now it has 18 electrons and only 17 protons. So because it has gained a negative charge, there is now a negative sign next to the atom's name. So this is something that, again, we will practice in class and you'll get a lot of practice with, especially when we're talking about types of bonds. But just remember, when we lose an electron, we become more positive. When we gain an electron, we become more negative. So it can kind of feel a little opposite. Lose an electron, you become more positive. You gain an electron, you become more negative. All right, thank you guys. Have a good rest of your day.